And welcome everyone, and it's your boy Abhi here. And it's been quite a while we uploaded the last video, and today we are going to start our new year with a cool transform which we never seen that before. It's kind of familiar with the Laplace transform, but today we are going to solve this quite looking integral which involves Mellin transform. And okay, cool. So what we have here is, which is I equals to 0 to infinite sine x minus cosine of x over root x times ln x dx. Well, okay, let's start with our new January integral. Okay, and we know that the Mellin transform of f of x is equals to 0 to infinite x to the power s minus 1 times f of x dx. Well, it's a powerful transformation. We are going to use this one as follows. So if f of x is sine of x, we'll get the answer 0 to infinite x to the power s minus 1 times sine x dx, which is equals to gamma of s times sine pi s by 2. The same thing we follow for cosine of x. The Mellin transform of cosine of x equals to 0 to infinite x to the power s minus 1 times cosine x dx. The answer will be the same, that gamma of s times cosine pi s over 2. And okay, cool. So let's generalize the integral as follows. This is the required integral. We'll take that integral as I of alpha equals to 0 to infinite sine alpha x minus cosine alpha x over root x times ln x dx. Okay guys, now let's move on. Doing a substitution, when x equals to alpha u, we'll get dx equals to alpha du. And okay, now the Mellin transform of sine alpha u becomes 0 to infinite alpha u to the power s minus 1 sine alpha u dot alpha du. Doing some simplifications here, we'll get alpha to the power s 0 to infinite u to the power s minus 1 times sine alpha u du. Okay, cool. So if you take a closer look at this integral, this is just the Mellin transform of sine alpha u. So we can write alpha to the power s and the Mellin transform of sine alpha u. And we know the answer for gamma of s times sine pi s by 2, because there are no x variables, so there won't be any change in the answers. So finally we have the answer for the Mellin transform of sine alpha u is equals to gamma of s over alpha to the power s times sine pi s by 2. If we follow the same instructions, we'll get the Mellin transform of cosine alpha u is as gamma of s over alpha to the power s cosine pi s by 2. And we need this answer to solve the integral. Let's move on to page number 2. So we need the integral. Let's write it down first. I of alpha 0 to infinite sine alpha x minus cosine alpha x over root x times ln x dx. Well, we have the answers for the Mellin transform. Let's name this as 1 and this as 2, so we can get, let's subtract 1 by 2, so 1 minus 2 will become, we'll have 0 to infinite, we'll get, the Mellin transform of sine alpha, let's name this as x so it won't be change anything, and the Mellin transform of cosine alpha x, which is equals to, well, let's take gamma of s and alpha to the power s, and we are left with sine pi s by 2 minus cosine pi s by 2. And we know that the Mellin transform is just 0 to infinite x to the power s minus 1 sine alpha x, and let's take this as common. So we are finally left with this integral we have here, which the answer is same as follows. So, well, now we need another logarithm down there. So let's differentiate both sides with respect to s. So we'll get uh, 0 to infinite x to the power s minus 1 sine alpha x minus cosine alpha x. When differentiating both sides with respect to x, we'll finally get the logarithm of x dx. And the right hand side, let's take this part as I2, and I'm going to differentiate both sides with respect to s, so we can get gamma prime of s times alpha of s minus alpha to the power s times logarithm of alpha times gamma of s over alpha to the power 2s, which we multiply by the same sine pi s by 2 minus cosine pi s by 2 plus gamma of s over alpha to the power s times, when differentiating sine pi s by 2, we'll get pi by 2 cosine pi s by 2 plus pi by 2 times sine pi s by 2. Okay guys, so if you see this integral, when we plug s equals to half and alpha equals to 1, we get the required integral, which is, let's take s equals to half and alpha equals to 1, we'll get I equals to 0 to infinite, and this integral will become x to the power negative half times sine x minus cosine x times logarithm of x dx, which is equals to, well, when alpha equals to 1, this one becomes 0, and also when s equals to half, this one will leads to 0, so this whole part will become 0, and we are finally left with only the required part, which is gamma of s. We can write this as the answer, which is gamma of half over, this is just 1, so we don't have to write that. Final left with pi by 2 times cosine pi by 4. So cosine pi by 4 plus pi by 2 times sine pi by 4. Okay folks, so now we have our integral, which is 0 to infinite sine x minus cosine x over root x times logarithm of x dx is equals to, we know that gamma half is just square root of pi, and inside we have 2 times pi over 2 root 2, which is this one, and this one will cancel each other out. And finally we have the answer for our required integral, which is I equals to pi times root pi over 2. And here we go. This is our gorgeous looking answer for the required integral we have here. Well, it's been a while using some transformations. Well, this one's new. Go ahead and try some of the integrals exercises using the Mellin transform. It's just the same as Laplace transform. So that's it for tonight, guys, and until then, bye bye from Abi, and please do subscribe to my channel, and that's it. Bye guys, see you from the next video.